All right. I'm assuming that now that more people are joining in, that uh, crisis has been averted. Uh, um, Anthony, if you're here, yep, you are. Thanks for letting me know about that hiccup. And there we go. All right. So, sorry about that hassle. Before we begin, can y'all hear me? All right. Jason can. Wood can. All right. Okay. So, my goal for today is just do problems on power series because um, essentially the main goal of chapter 11 is power series. And so the best way to learn is to get our hands dirty and to figure out how to do that. So just going to the first problem I'm going to ask y'all to work on. For the power series that I'm going to give you, find the center of the power series. And find what I want is both the radius of convergence and the interval of convergence. And the first power series that I want you to try that on is the sum. K goes from 1 to infinity, -1 to the kth power, x to the k over the cube root of k. So again, thanks, Unique. All right, so like I said, for yes, I'm going to assume that y'all watched the video on 11.2. And so what I want y'all to try to do is, in the comfort of your own room, find the center of that power series, and also try to report the center and radius of convergence for that. I'll give y'all about 10 minutes to work on that. If y'all have answers, go ahead and post them on the chat. Or if you have questions, also post them on the chat. I think a couple people join. Yep. If y'all recently joined, essentially I want y'all to try to find the center of that power series and find the radiance and the interval of convergence. All right, let me reply to a message I got. So while y'all are working on that problem, give me a status report. How's that problem going for y'all? Thanks, Isaac. I'm guessing you just joined. So work on that problem and around 3:50 we'll reconvene. Yes, we are. We're on 11.2. So we're going straight to power series. Alrighty. Give me a status report, y'all. How's that problem going? All right. So I'm assuming that y'all are working diligently on that problem. So let's go ahead and start. What's my center for this power series? Keep in mind that the general form for a power series is that some coefficient with respect to the index, x minus a raised by a power. So, first question I have, what's my center for the power series in problem 1? Can anyone hear me? Like any responses? Okay. Alrighty. In that case, let's dissect. So, my general form for a power series is always in that form. Some constant with respect. It's okay. We're going to go through this together. So, in this case, this is some constant with respect to k. So, in other words, it's a constant that's changing with respect to my index of the sum. And the reason why it's called a power series is because it has the variable x raised by the power of the index. And whatever that number a is, that's what I'm referring to as center of the power series. And so in this case, in problem 1, because I just have x raised to the k, I can rewrite that as x minus 0 raised to the kth power. Which means in this problem, my power series is centered at 0. And also in this case, let's go ahead and list out C of k. It is the coefficient that is not with the s to the kth power. So it would be, in this problem, -1 raised to the kth power divided by the cube root of k to fit in our formula. And so now, let's go ahead and talk about how we define a radius of convergence and an interval of convergence. And essentially, this is why we care about all of our convergence tests from chapter 10. And I'll go ahead and tell you right now that for yes step, 99% of the time, you will want to use either the root test or the ratio test. And the reason why I state that is because, recall from the video, the radius of convergence is some positive number r such that x minus a is less than r. And the reason why it's called the radius of convergence is tells me where my power series is convergent. And so the reason why I want to use ratio or root test is because we know what makes root and ratio test convergent. We know that if it was the ratio test, so this guy would be convergent if this thing is less than 1 for L. And so, and then for root test is the same, similar, only difference now, it is the kth root of the absolute value for A of k. And the reason why when finding the radius in the interval of convergence, I recommend using either the root or ratio test is because we know already what inequality makes that series convergent. Less than 1. And so what I'm going to do is I'm going to rewrite it to give me in that form. So let's see how we do that for this example. And for this example, I'm actually going to use the ratio test. The reason why I'm choosing ratio test instead of the root test is because for my C of k, it's not k raised to the kth power, it's k cubed, which won't really help me in this case. So I'm going to stick with the ratio test and see what that gives me. And in this case, when you're talking about the ratio test, my A of k is still going to be the same setup as before. The only difference is now I have x popping in there. Oh, and that needs to be k plus 1. So with that, let's set up L. L is the limit as k goes to infinity of the absolute value of A of k plus 1 over A of k. And like we talked about before, ratio root test, we're going to take the A of k plus 1 power and multiply it by the reciprocal of A of k, cube root. So cube root of k divided by -1 to the kth power x of k. Now let's try to simplify that guy. I have -1 raised to the kth power, have -1 to the k plus 1 power, so I'm just left with one -1 term, which because I'm inside the absolute value is going to go away. I have x raised to the kth power, I have x raised to the k plus 1 power. So that means I just have one x term coming in. And then I can't do any cancellation with the cube root of k and the cube root of k plus 1. And so now my next step after that, I'm going to isolate the x away from everything else. So -1 times x times the cube root of k divided by the cube root of k plus 1 in the absolute value. So once I get to yes step, I'm going to provoke a property of absolute values. One property I want to use, if I'm taking a product of two numbers and they're inside the absolute value, it means the exact same thing is if I take the absolute value of the first number and multiply it by the absolute value of the second number. And I'm going to do that by separating those two, where the -1 times x will be my a, and the cube root of k over cube root of k plus 1 is my b. And also for yes term, I'm going to simplify it even further because they're both cube root, which means that they're both being raised by the 1/3 power. And so I'm going to provoke the property that quotient of two numbers with the exact same power is equal to that quotient, and then that whole quotient being raised by that power. So with that, let's go ahead and use our property of absolute value, limit, as k goes to infinity of -1 times x in the first absolute value times absolute value of k over k plus 1 raised to the 1/3 power. So a couple of notes that I'm going to make. The first note is that the cube root of k plus 1, 1/3, that's always going to be positive because k is the index of my series, so I'm starting to get 1, 2, 3, and so on. So that's always positive, which means the absolute value here is redundant. The second note I'm going to make, I have a product of two numbers here again, so I'm going to use that property one more time and say that is the absolute value of -1 times the absolute value for x, and the absolute value of -1 is 1. So I'll just be left with the absolute value for x. Now, I'm not getting rid of the absolute value for x because I don't know which interval x is in. So I'll make that as a next note. That because I do not know which interval x is in, I'm going to keep the absolute value because I don't know if it's positive or negative. If it was positive, great. If it's negative, then I'll get a positive number again. So I'm actually going to keep it for that one reason. And also another reason why I want to keep it is I want to eventually get back to that definition of a radiance of convergence. So with that in mind, I can now rewrite the expression in star as the limit as k goes to infinity of the absolute value for x times k over k plus 1 to the 1/3 power. And now here comes my next note. I'm taking this limit with respect for k. Do I see any k with that absolute value for x? Go ahead and type your comment below. Since I do not see any k in there, so recall back from 1060, what's something that I can do with that absolute value for x with respect for the limit? not going to be 0. Bingo, well, I get to pull it up front because since I do not have a k with that, I get to treat that as a constant with respect to k. So I'm going to make that as a note why I'm treating it like a constant. I have no k's with that, and I'm taking my limit with respect to k. So I get to use my limit property that says constant with respect to the limit gets to go outside, and then I just take the limit of what's left behind. And if we evaluate that limit, I'll go ahead and tell you that we're going to get 1. And the reason why we're going to get 1 is the cube root is continuous, so I can move the limit inside the cube root and take the limit of k divided by k plus 1, which will equal 1. And so with that, I now have that capital L for the ratio test is now just equal to the absolute value of x. And because we get, shouldn't it be affinity over affinity? So let's go over that in more detail because I think there's a little confusion. So what I used, Anthony, was cube root is continuous. And so because it's continuous, I can move that limit inside the cube root and get that. And I have the ratio of 2 rational numbers with the same with the highest power in the numerator and denominator equaling each other. And so because of that, I'm using my shortcut from Tensysty that says, since the power on the numerator and denominator are equal, I just read off the ratio to coefficients. Yep, no problem. And I agree, James, it is wild, which is why we're going over it, because sadly for power series, it's not going to be as nice as with series, because now I got to tell you, you got to tell me where I'm converging. Yeah. And yeah, you're correct, Anthony. You'll still get 1 anyway, so rip. All right. And so now here's the fact why I want to use ratio tests. I'm now going to put less than or equal to 1. And the reason why I want to use less than or equal to 1 is because we know back in chapter 10, by the ratio test, that L that we defined earlier, the way to have a convergent series is if we set that less than 1. And so what I'm doing is, because I did the ratio test and because I know what makes the ratio test convergent, what this tells me is the following. For the power series, to be convergent, I need for the absolute value for x to be strictly less than 1. So that is my number 1 condition that I need at the very end. I did my setup for the ratio test, took the limit of my 2 ratios. I simplified it down to just to equal to the absolute value for x, which means for a series to converge, I need for all of my inputs for x in terms of absolute value to be strictly less than 1. And because of that, one will be my radius of convergence. Because it's essentially the number that I cannot exceed if I want to maintain convergence. So yeah, we did a lot of work just for that part, and we're still not done yet. Because all we got was the radiance, and we still need the interval. So let's now go through how to find the interval of convergence. I say once you know the radius of convergence, we get the profit. Yes, there is. I should have posted a link for the 11.2 notes on Canvas. If you want, I can repost it. Yeah, it's in the announcement. Thanks, James. Well, like I said, this stuff is already hard as is. So let's go through. All right. So we concluded previously that the absolute value is less than 1. The idea from that is if I claim the absolute value is less than a number, then it's the exact same component as me saying whatever's inside the absolute value is larger than negative 1, but less than positive 1. And you kind of get an idea of what that means. Does it go away? Is to say that was 0, because absolute value is take the positive number of that, I'm essentially saying that any number that satisfies that inequality must be within the interval -1 to 1. And so to find the interval of convergence, essentially the main idea is to use your radius of convergence, rewrite the absolute value as negative of the radius of convergence and positive of the radius of convergence. And let's go ahead and write more general. If I actually had a center that's not 0. And then if I had, say, the center was 1, I would add a to everything. To rewrite that as a minus r is less than x is less than that center plus the radius of convergence. So in general, this will be the basis of the interval of convergence. All right, so before we go back to our specific example, does anyone have any questions on that concept? All right. like I said, post your questions on the chat. I'm going to now jump back to our original example. So as mentioned before, I could rewrite an absolute value less than a quantity as -1 less than x less than 1. And so what that tells us is my interval of convergence is going to be -1 and 1. But as you all note, as you see, I didn't include any open parentheses or a closed bracket with that. And the reason why I did not include it yet you have to do a little bit more work now, and you have to state, can I include or cannot include my endpoints -1 and 1 in my interval of convergence? And a way to check that is we're going to plug in our endpoints for the value for x in our series. And we're going to use our test to check and see whether or not my series converge or diverge. And so with that, let's go ahead and write back down our original power series. And now because I'm plugging in -1 to check if I can include the left endpoint, this can now be rewritten as -1 to the kth power, -1 to the kth power, because now I'm plugging in -1 for x, cube root of k. And now I have -1 of k times -1 of k. Multiplying those two together, I have -1 to the 2k power over the cube root of k. And because it's always going to be an even power, negative number raised to an even power will get rid of the negative sign. So I'm now left with 1 over the cube root of k. And now we have to check for convergence or divergence of this series. And so based on all the series tests that we've done, for the series 1 over cube root of k, all right, I agree it's a p-test. And what's my p in this case? Yep, 1/3 less than 1, which means I have divergence. And so what that concludes in my interval of convergence is I do not include the endpoint -1. So that tells me that at -1, I have an open parentheses for that. So now we get to repeat our work. And now I plug in +1. So -1 to the kth power. And now wherever I saw an x, I'm now going to replace with a +1. A 1 raised by any power just gives me 1. So it's going to be -1 raised to the cube root. So based off that series, what test should I do to check for convergence or divergence? Type your answer on the chat of what tests I should be using. Yep, and I agree. Alternating series test. So, gotta do the first step. Check that my positive term is non-increasing, in which case b of k is 1 over the cube root of k. And now we have to check that this guy is decreasing or non-increasing. So I'm going to define f of x as 1 over the cube root of x, or x to the negative 1/3. Domain 1 to infinity, because that's where my series began and where my series ended. My first derivative is negative 1/3 x to the negative 4/3. And I don't care what number you plug into that domain, you're going to get that will always be less than 0. So first condition is checked off. And I say second condition is very quick as well. Because 1 over cube root, k is only in the denominator. So denominator is getting really big, which means the second part is 0. So that tells me that if I plug in x equals 1, I get a convergent series, which means in my interval of convergence, I include the right endpoint, which tells me that my overall interval of convergence is negative 1 to 1, open parentheses at the left endpoint, close parentheses at the right endpoint. Now that was something pretty epic. All right. So, any questions about that problem? Any questions about that problem before we go on? Or any about the methodology? Because for power series, that's going to be our method to solve these types of problems. So as an answer to summarize, Anthony, let's go ahead and summarize. Radius of convergence was 1. We found that the interval of convergence was negative 1 to 1, where my center was 0. So those are the 3 things we were looking for. What was the center of my power series? What was the radius of convergence? What was the interval of convergence? And that's going to be mainly what we write as our answer for that. All right, so before I give y'all another problem, let's kind of recap kind of our methodology, because I claim that our methodology is not going to change. Our methodology is, from our power series, we're going to mainly use either the root or ratio test with the x to form our radius of convergence R. And the reason why we choose either ratio or root test is we know an interval what makes that convergent when that limit is less than 1. And we do our work for either the root or ratio test, treating the absolute value for x minus a as just a constant. Take that outside of the limit, and we'll get an expression just x minus a or something like that is less than 1. If we have a coefficient in front of the x, that's when we're going to divide by the coefficient. So for example, if we did all that work, let's say I had 2x, then I would divide both sides by 2, and therefore my radius of convergence would be 1/2. And then from that, we're going to use our radius of convergence to form a preliminary interval of convergence. And then we have to check the endpoints by plugging them in to get our final interval of convergence at the very end. And that's going to be our methodology for all of these problems. It's a lot of work, but it's pretty cool. So I think with that methodology kind of ironed, I want to get y'all another one to practice. Here I'll choose n for the index. And here's going to be our new power series. And again, I want y'all to repeat. I'll answer your question soon, James. Let me finish explaining for you. So again, I want y'all to now, with us walking through that first example, try it again with this power series. Find the center, figure out what the radius of convergence is, figure out what the interval of convergence is. And for that, I'll give y'all until like 5:15, and then we can walk through it together. And James, to answer your question, I haven't heard from the coordinator yet about what her game plan is. I'm hoping to hear from her soon about the final. From what she's talking about, she's thinking about doing it online. But as of how she's going to administer it, I have no idea. So I will let you know once I hear from Dr. Burr, our course coordinator. That's up to Dr. Burr. If it was up to me, I would say yeah, because of what the university has to say. But because this is a coordinated class, it is up to the course coordinator with what she wants to do. Like I said, it's up to Dr. Burr. It's not up to me. If it's me, I would say, yeah, we can do that optional policy. Isaac, you're assuming way too much of me. For that, James, I don't know how Dr. Burr is going to do that. I think she's still scrambling to try to figure that out. So hopefully we will let you know as soon as we can. All right. All right. So go ahead and So go ahead and try that problem out. And yeah, we could do that, Isaac, after class. But first, go ahead and try this out. And I'll give y'all until like a quarter till, well, let's do it till, since our Zoom meeting ends at 5. Let's do it at 4:40, so that way we have time to go over it. So a message for me, so I'm going to respond to that real quick. Let's see. So the reason why we do the interval convergence, Anthony, is this tells us where the power series is convergent, not the interval. So what that interval tells me is the interval where the power series converge. So that's why we care about the interval. It doesn't tell me for every interval. It tells me where the power series converge. Is that kind of clear your question, Anthony? All right, you're welcome. And this is definitely time to ask these questions because this is where the rubber meets the road. Let's see a message. Let me reply to that. And if y'all have questions while working on that problem, post those on the chat or unmute your mic. Not equal, but less than. Because remember, for the radiate circumference, if you're using root to ratio test, you're abusing the fact that L is less than 1. And you're going to use that to essentially give you your radiance by dividing by 10. So I say you're close, Unique. but it's not equal to 10 times the absolute value of x. But if you divide, you'll get answer for that, for the radius. Not r less than 1/10. I say that r is 1/10 because what you have is did all your work for the limit, and you have a less than 1, and you got it to be 10 times the absolute value. And so then I want only the absolute value minus the center on the left-hand side. And so I'll have absolute value divided by 1/10. So now I say you have your radius of convergence. Goody. All right, so for the sake of time and to get to Isaac's question, I'm going to go ahead and start walking through the solution. Before I do that, Catherine's here with us, so I'll let her make the announcement now. So if you want, Catherine, you can go ahead and unmute and talk to all of us.
Hey guys, can y'all hear me? You can let me know in the chat. Yeah, so we still have PAL going on, same times. So if y'all have any questions, it's probably going to look different than normal PAL sessions. So if you literally just have one question and want to pop in, do it. So yeah, but I'll still have specific problems and stuff that we can go over. But yeah, seriously, just use me as a resource, and yeah, because I'm here to just help y'all get through the class. So yeah, keep working hard, and I think that's all I have. So yeah, thanks.
All right. And her student link and her ID, I posted it on Canvas.
Oh yeah.
And so that is not going to change. That, if I remember, Catherine, you said that's pretty fixed throughout the remainder of the semester. So just click on that link always, and you'll be at a PAL session with Catherine.
Cool.
All right. And on that note, Let's blow his popsicle stand and get through the example. So what's my center for his power series? Yep. A is 0 because I have nothing to go with that. And so, out of curiosity, what test did y'all decide to use for this problem? Ratio root test. Yep. And I agree. For yes, we'll use ratio test. If I can spell ratio. And the way that so the way that it's going to affect, I'll answer your question a little bit later, Anthony, because I'll show you how it will affect not 0 a little bit later. But I'll get to the point where we just have the absolute value for x and kind of explain that real quick. But for now, let's go through the series. So since y'all did ratio test, when y'all did the limit as k goes through infinity of a of k plus 1 over a of k, what did y'all get for your number? Or what did you get after you did all your simplification and limit evaluation? All right, Unique got his answer. Anyone else? And also note that I'm using k, but my series is n. All right, and I agree, Anthony. I agree, Unique. It's going to be 10 times the absolute value for x at the end. And with that, because I know what makes the ratio test convergent, I'm going to set it to be less than 1. And so because I have that coefficient of 10, I'm going to divide both sides by 10. And I will get absolute value for x less than 1/10, which means that 1/10 is the radius of convergence. And now to answer your question, Anthony, if the center was not 0, that's going to affect our interval of convergence at the very end. And the reason why is, let's copy down here in pink. Let's say I had x minus 2 less than 1/10. Then the way that's going to work is we do our same step as before. And because now I have, it's going to shift it by wherever the center is. So you're exactly correct. Which means x will be, in this case, 2 minus 1/10 or 2 plus 1/10. Or 19/10, 21/10. So that's exactly right, Anthony. It's going to shift where my power series is centered. Therefore, when we do our work, it's going to shift what our interval of convergence is based on what our center is. So you're exactly right. All right, so back for our example. I'm going to guess that based off our work, y'all got the power series to be, or the interval convergence to be negative 1/10 to 1/10. Out of curiosity, when y'all were doing this work, do we get to include the endpoints, or is it going to be open bracket? All right. So Unique said that he included both endpoints. What about everyone else? What did y'all get? All right, fair enough. All right, Jason responded. All right, yeah, appreciate it. All right, and I agree with. Alrighty, and let's go through why that's the case. X was positive 1/10. Plug that into our power series. 10 to the nth power. 1/10 to the nth power over n cubed. Because 10 to the nth and 1/10 have the same power n, I get to combine them together into 10 over 10 to the nth power, and 10 divided by itself is just 1. And Isaac, I just read your comment, and that made me giggle a little bit. All right. And the reason why we get to include the right endpoint is because P is 3 greater than 1. So by P series test, that's definitely going to converge. And let's do negative 1/10. And I'm going to say the work is going to be essentially the same. But you'll have, instead of 10 to the nth over 1/10, you'll have So Unique, based on your comment, I'm assuming you just read Isaac's reply. Wonderful. It's becoming more like a Twitch stream every day, I do guess. But anyway, so, and with that, we would use the alternating series test to conclude that that is convergent. Which is why we have both endpoints included in our radius of convergence. All right. Any questions on data sample? All right. In that case, Isaac, I can go ahead and answer your question on MyLab Math 11.1. If it's easier to unmute your mic, go ahead. I could go ahead and try to answer that question. All right. I think I'm able to hear you.
Can you hear me?
I can.
Ah, wonderful. Okay. So on MyLab Math today, I was doing number 11.
Okay.
Hey, I'm pulling up right now. Okay. So we had to approximate maximum error for a function. And I am curious because I couldn't exactly, I got caught up finding the m value for my function.
Okay.
So to list specifics here, I'll get it back. So they wanted f of 0.2 and f of 0.4 of the function f of x equals sine x.
Got you. Okay. So let's write that down.
Okay.
You said f of 0 and then f of 0.2?
They wanted f of 0.2 and f of 0.4.
Oh, I got you. Okay.
Yeah. And the format for the answer was the maximum error is approximately blank for, and then it was multiple choice on what our capital M value was.
Okay, got you. All right. So out of curiosity, I'll pull the problem up on my end.
Okay.
Did it ask you what for the remainder? Did it ask how many derivatives you have to take or anything of similar nature?
Let me see. It was, yeah, on part A, it just asks me to find the maximum error.
Okay.
They've asked me what f of 0.2 was as an approximation.
What question number was it?
11 on section 11.1 homework.
Cool.
All right. So let's pull that up.
On previous problems, like number 10, they asked for a remainder and they kind of, using the help me solve this or the example problem,
Okay.
they guide you through plugging in remainders and finding the n value, but they're asking for.
Okay, so alrighty, so I have the problem pulled up.
Yeah.
Okay, so it's asking when n equals 2.
Yes.
Alrighty, so let's walk through this then.
Okay.
So what that tells me is, for what it looks like first step is I need to approximate f of 0.2. And so what that means is, first, I'm going to find the second order Taylor polynomial.
Yeah.
Using our formula. And because my center is 0, that's why I'm not including ds minus a, because I know in this case a is 0. And then once I get my polynomial, I'm going to plug in 0.2. And so let's walk through that then.
Okay.
So f is sine, which means sine of 0 is 0. Derivative is cosine, so that will equal 1. Second derivative will be negative sine. Evaluate at 0 means that whole thing is 0. Which means I am just left with the line y equals x for my answer.
That's why f of 0.2 approximates to 0.2.
Yep.
That is very fabulous.
That's right. So I'll put this down here to make that more clear.
Okay. I'll write that down on my end as well.
Alrighty.
Nice. Okay. So now that we have established that f of 0.2 is indeed 0.2, the next step, I know it's little things, right? The next step is to find the maximum error. So I have to decide what capital M equals and what the actual maximum error is. So this is, I believe you have to find 3 of x is less than and take the next lowest value.
Right, so let's go through that. So what that is asking us to do is we're trying to use our estimation for the remainder theorem, which is m over n plus 1 factorial over x minus a, where less than or equal to m, where c is some number inside where my center is and where x is. So let's go through first how we can get that guy.
Okay.
And then we could walk through there. So since I know what x is 0.2, and I know my center is 0,
Mhm.
I could just replace that with the interval 0 to 0.2.
Gotcha. Oh, would you mind scrolling up for 1 second? I
Tell me
forgot
when
to write
stop.
that. Yep, right there.
Okay.
At equals x. So that's bracketed to 0, 1, 0. Okay, that makes sense. Thank you.
Alrighty, you're welcome. All right, so I know C is a point between 0 and 0.2.
Mhm.
So let's first go through this guy because you said you were fixated on it a little bit, or
Yeah, that is what piques my curiosity here.
all right.
Is that an M or a mu?
That's supposed to be capital M.
Okay.
Yeah, my
Kind of got that italicized look to it.
yeah, my handwriting on touchscreen sucks. So
Oh, no,
you're gonna have
great.
to
I
take
feel
that with
that.
a
I'm a lefty, so I can't write a
Oh gosh.
smearing. I can't write on whiteboards.
Nice.
One of my roommates is left-handed, and he feels your pain.
You know, Anthony, you could technically write with a Sharpie on a whiteboard.
I have done that before.
I mean,
Not on purpose, but
Talk about regrets later.
just
yeah.
have to like clean it with sunscreen, I guess, right?
I wiped it off real fast and was able to get most of it off.
Oh, nice.
Oh,
Okay,
yeah.
so Rn of x, that is
Alrighty.
some
So
fancy labeling here, is less than m over m plus 1 factorial. That is fantastic.
so let's rewrite that for this example or
Okay.
for this problem, because right now that doesn't really help me in a general form. So let's go more specific.
Let's go more specific, yes.
So in this case, since I approximated with the second order Taylor polynomial, n is going to be 2,
Mhm.
which means this transforms into n plus 1, which is 3 factorial x. But since I know that a is 0, I'm just going to replace it with s absolute value of 3.
Fair enough, fair enough.
Which means for the bound that I want, third derivative of c has to be less than or equal to m. And so what we're trying to find is from the third derivative, what is going to maximize this guy? And so let's go through that.
I really
First
think
thing,
m is a 1 in this case. Right?
what do you think is 1 out of curiosity?
Because f3 of c would be f prime, or the third derivative of sine x plugging in our value of c, correct?
Yep.
Right? And so the negative cosine of 0.2, that is, hang on a minute, I did this calculation earlier. Yeah, 0.2 cosine. Yeah, that the absolute value of that at least is 0.98. So I'm getting a sneaking suspicion here that that's less than or equal to 1.
Guess what? I actually agree with you, Isaac.
Oh, fabulous.
Because, so I'm not going to write down the negative because I'm inside the absolute value.
Yeah, it kind of doesn't matter.
But here's another reason why I agree with you. What's the largest possible output for a cosine function?
The largest possible output is 1. Oh, wait. Yeah, that just gives it away, doesn't it?
Yep.
Oh, it's too easy.
So that's why I agree with you.
Okay, well, I'm going to make a note of that because I always seem to forget that cosine's really just like 1.
So let's pretend it wasn't sine or cosine that we were working with. Let's talk about the dot process of how to do that.
Okay.
So let's say I had still second order polynomial, but let's say it was square root of x.
Uh-huh.
So that means I need the third derivative. So let's go ahead and take those derivatives. So 1/2 s to negative 1/2. Second derivative.
Yeah.
Negative 1/4. S to d negative 3/2. And then third derivative of that guy will be 3/8 s to the negative 5/2. Since I plugged in c, I would replace that x with a c. And so typically in general, if I wasn't working with sine or cosine, where I could quickly get a bound like that, the question I'm going to ask is, is that function increasing or decreasing?
Oh, I
And the
see.
reason why I asked that is at this point, we know what interval we're working in. If I know the function is increasing, then I'm going to plug it. Then this will be bounded by, let's give actual numbers. Let's replace a and b so we can play with that. If I knew it was increasing, then my bound will be plugging in the right endpoint.
Mm-hmm.
And that will form my m. If it was decreasing, I would change that by plugging in the left endpoint.
Mm-hmm.
And that will quickly get my bound. If it's still something nasty, so one example 11.1 I gave was e to the 0.045.
Yeah.
If that's the case, you can still abuse the fact that I'm increasing or decreasing.
Is that the smartest way to go about it every time? Is to just find the derivative there?
Right.
What if it's like some crazy like f to the 8?
Oh, geez.
Or will it never be that bad for us?
You can assume for this class, Anthony, that I will proofread and make it not that bad for y'all.
Okay.
Oh, that's very sweet.
Thank you.
It's that personal touch that I love.
It's an April Fool's joke.
I'm convinced that 11.2 is actually an April Fool's joke.
Probably.
Most likely.
Wonderful. Yeah, the entire Zoom meeting was an April Fool's joke.
Yeah, I knew it.
All right.
It was password locked, so maybe.
Yeah, that's all I was thinking.
Yeah, you did. I was playing coy.
It's a prank.
All right. But yeah,
Anthony, just trying to weed me out.
But yeah, Anthony, the short answer to your question, that would be the best way to go about it, is to figure out if the n+1 derivative, if that was an increasing or decreasing function.
Okay.
All right. Oh, Unique. So
Unique is very handsome today.
like I said, the more I do this, the more I should just do this on Twitch.
Yeah, the Twitch chat at least has all those emojis that you can use.
Well, considering that Zoom is sanctioned by the
dropped 100 bomb.
Well, the reason why I'm using Zoom is Clemson University is strongly encouraging people to use Zoom, and so I'd rather use what they sanction instead of going on my own path.
That's weird. Zoom's under fire for a lot of data privacy breaches.
Yeah, I saw that. I actually read that email during it, and I'm like, oh, geez.
Well, I mean, university data privacy and Zoom data privacy might go hand in hand here.
Well, if someone steals my identity, they're not going to get much. So
give up your rights.
All right, so let's finish this problem to clarify.
Yes.
So
it's a little like intimidating just to see all the kind of the theory written out, but it does make sense that just taking the third derivative or even recognizing cosine properties would lead you to the right m value.
Correct. All right. And like I think I said to James when he posted on the chat when he said this was wild. Power series is let's just say this is where it starts getting harder. So
Uh-huh.
if it's difficult, that means you're learning. So I
Well,
understand.
It's not that difficult once you like learn it. Like once, like I was able to do the second one by myself.
Oh, really?
Yeah, I mean, I looked at the first example, of course, but
Mhm.
Well, like I
I
said, that's
understood.
why.
I understood what to do.
And I'll tell you right now, and I'll tell you right now, like that's why we did series. And later on, there's the reason why we do power series is because Taylor series is based off of power series. So
Oh, fabulous.
so yeah, everything is cumulative.
Oh, man.
All right. So I plugged in the M, and now I need to figure out what to plug in here.
Yes, that is the question.
And so I asked the same question.
Mm-hmm.
What will maximize x in that interval? So, and the interval that we're working on was 0 to 0.2.
0 to 0.2. Okay.
So ignore the absolute value.
Why is it 0 in this case? Why isn't it?
Oh,
Never mind. It's because A is 0.
yep, that's why.
It took me a second. I was looking at the 0.4. I was like, shouldn't it be from 2 to 0.2 to 0.4? But that's no.
No, you're good. Yeah, we're not at the 0.41 yet. So, but yeah. And so that's how I think about the S2, Isaac, is what's maximizing that guy. And so just like with how we got the bound for M,
yes,
I'm still asking that same question and saying, okay, what do I need to plug in? Is it increasing or decreasing? And by that tells me whether or not I'll plug in the left endpoint or the right endpoint.
Oh, okay. So if I plug in the right endpoint,
It's gonna continue increasing if you take the derivative.
Bingo.
Thank you, Anthony.
You're welcome.
Which means in that case, it's going to be smaller than if I plugged in the right endpoint. And that should give us now our maximum error for that guy.
Wait, isn't it going to be bigger if you plug in the right endpoint?
So we're asking for the maximum error?
Oh, maximum error.
Yeah.
Okay, well, plugging this in here, 1/6 is a tiny number, but 0.2 cubed is also tiny. So let's go 0.2 cubed is 0.008. And if we multiply that by 0.16 repeating, that gets us 0.0013 repeating. So that's going to equal 0.0013.
So I'll tell you from my end, I got scientific notation. So.
Oh yeah, so that would be, or hang on a minute, that would be 1.33 times 10 to the negative third.
Alrighty.
Is that?
And there's our maximum error.
Ooh, okay, well, that's interesting. Let's check that. Oh my goodness, it says well done. You know what I had one incorrect answer. Do you know what that value happened to be? It was 1.3 times 10 to the negative third.
I'm guessing. Oh.
Yep.
In that case, that was just Mile on Math being like silly and just not
dumb.
accepting. Yeah.
It did tell me to round it 2 decimal places, but oops. All right. Well, that's a relief. I'm glad that I could get that figured out.
All right.
So basically, that the step-by-step here is. Hang on, let me highlight this. Okay. Step-by-step is find M, take your specified derivative of your value at x,
Mm-hmm.
plug that in. Make sure you can write theory and look very fancy doing it. That's kind of like the middle section. And then MyLab Math will reward you handsomely for it.
Yeah, then you can, and then for your answer, you could be like Salt Bay and just season it with salt if you want
Exactly. I
Marinate
love
it.
that train of thought.
to.
Okay, so then to get R4 of x, wait,
Same
R2
process.
of 0.4 is the same process. So
Yep.
taking the absolute value, that would be less than 1 over 3 factorial times the absolute value of 0.4 cubed. That itself would be less than, okay, we're gonna do this again. So 1/6, we're gonna use that result, times, and then 0.4 cubed. Okay, so then that equals 1.1 times 10 to the negative 2. In scientific notation, of course, because my lab really likes that. So that would be 1.1 times 10 to the negative 2. Ah, that's incorrect. I might have plugged it in wrong. Whoops.
Yeah. So luckily, Isaac, the only thing that's different
hmm
is instead of 0.2 is 0.4. So I claim that RM is still the same.
Yes, indeed. Why didn't that work? Times 1 divided by 6. I got 0.0106 repeating. Oh, because now instead of scientific notation, they want an integer decimal. I need to read instructions sometimes.
Oh, it's okay. Reading is hard. I understand.
Reading is hard,
It
right?
is difficult.
Okay. Awesome. Well, that about takes care of it. Whew.
And that's
What a-
ironic for me to say reading because I actually almost minored in literature when I was an undergrad.
Oh, nice.
But I decided to minor in chemistry instead.
Can you imagine Scott Scruggs, the English major? It's too powerful.
No. Oh no, it was going to be a minor. Yeah, it was because like I went to a liberal arts university, and so it was required for everyone to have a minor.
Oh, really?
Yeah, so I was like,
I see. I would love a minor, but I can barely keep up with engineering. So
Yeah.
Yeah.
yeah, it was. The only reason why I was able to not die was because I came in with college credit already.
Oh, that's smart. See, I decided not to. I was like, I'll retake all my classes, but that didn't work out good.
Sorry, it's about the journey, right? Not the
Yeah.
destination of.
I wish I had taken 1080 last semester, because 1060 I really didn't need.
Yeah, I took 1060 also and came out with regret. So,
Which
however,
the whole part of 1080 that I wanted to like go back and relearn and like try to like really get the grips on is what we're learning now. We're not in school anymore. So
oops.
Oh,
Look at that timing.
I'm guessing you took BC.
yeah.
So I'm guessing that was
same
the
here.
hard part. Okay.
Yep. This is once we got to series and sequences, that's where it lost me.
Yeah.
Gotcha.
And then polar coordinates because I was sick one class. And that's when we went over polar coordinates, and I just never learned them.
Okay, yeah, polars and parametrics are kind of whack, but I'm kind of looking forward to them.
It was actually weird because parametrics was one of the first things that we did.
And what a bookend.
Yeah.
Okay, well, I think that's all the questions I had, unless we can just jump into that
Yeah, I'm
take-home
gonna
quiz.
head
But
out.
it's 5:15, so I'll give you a break.
Nah, fair enough. Out of curiosity, how are y'all classes going now that it's switched to online?
You can start, Anthony.
there's a lot more work. I would say.
Okay, fair. Yeah, that's
I would
what I
say
imagine.
Because like classes like sociology, I would just show up, sit there, and not do anything, and then I'd have a homework assignment due every Sunday night. But now every week she's making us read articles and watch videos and everything.
I feel like I'm
And
learning again. This is crazy.
I just don't like it. It's just not. That's not what sociology was. It now it like makes it harder because I have to worry about that on top of everything else. And then like physics, I know I'm behind because he posted videos over spring break that we were supposed to watch, which I just didn't. So I'm still have to go back and watch those. I've been trying to do a little bit every day, but
Yeah, why would our professor do that? It's like,
I don't understand that.
Yeah, that was why, like, for Take Home Quiz 9, I was like, okay, like, that's going to be due, like, yes, Monday, because...
yeah, that was a relaxed.
No,
Yeah.
I worked on that. I thought it was going to be due Friday, so I started ahead, and then
Oh.
Yeah, I thought it
no.
was Friday as
I
well.
wasn't like worried about it. I started it like Monday
Okay.
or whenever it was posted.
Yeah, yeah. I'm trying not to be a dick about it, so that's why I'm trying to work.
No,
Work
this
through
class
that.
hasn't been that bad.
Wise words. Wise words.
Oh, well, you're going to learn that now that it's online, I'm not going to be super formal anymore because,
Good.
like,
Cool.
yeah.
Yeah, I'm sorry I mess with you in chat every day.
Oh, no, I think it's funny. It
good.
does make me giggle. Last week was my favorite day when it was essentially like a Twitch stream.
Oh yeah, that was great.
Yeah.
First thing
Got
I
that.
saw was F in the chat. I'm like, oh, fuck. Okay.
We did that. We all did that in physics, and our professor was like, "What does F mean?"
Yeah, 200 students were typing F in the chat.
Oh, luckily, I just be glad that I have a sense of humor and I can, and I also like, my roommates and I, we do that all the time, so I am used to that.
Oh, that's great. Yeah, I heard that there's like there were other sections that aren't having as much fun as we are.
Yeah, from what I've gathered from at least the grad students who are teaching 1080, which are only 3 of us, we're having a blast in comparison.
Is there anybody teaching Calc 3 that you'd recommend?
I have no idea.
Okay.
So for next semester, I'm going to try to teach Calc 3.
No way.
I'm
That would
going
be
to
cool.
try. However, so
You have to post that in your announcements.
do you usually let
do.
professors to teach it? Well, here's the awful thing, Isaac, is for grad students who are teaching assistants, we don't really know until 3 days before the semester begins.
Oh, nice.
So yeah, so I didn't know I was teaching this class until the week of the semester beginning.
The luck of the draw. We're all gonna have to choose our slots very carefully.
Yeah, we're gonna have to play this very smartly.
I will. Yeah, like I taught 1060 last semester, and they were pretty upset that they weren't able to have me for 1080. But I taught a non-rise section, and from what I know, I think non-rise students can't be in a rise section.
No.
I'm right.
Officially,
Yeah. Okay, so that was why I didn't really let them know, because I'm like, I want y'all to be in here with me, but
laws.
Yeah, I can't
$500
really.
deposit.
Yep.
That's what separates them from us.
Wait, y'all have to pay extra money to be in the Rise program?
Yeah, that's the
it's
whole
like
thing.
$500.
Well, that's kind of annoying.
Yeah.
Yeah.
However, I'm very glad that went towards living in Lever Hall instead of Burns.
Yeah, me too.
Oh, okay. So I didn't do my undergrad at Clemson because I grew up in the upstate and I wanted to get away. So I have no idea how the dorms are. What?
The Liberal Arts College you mentioned. Where was that upstate?
I actually went to Francis Marion, which is an hour away from Myrtle Beach.
Ah, nice. So you had those Myrtle spring breaks, right?
Yeah, no. I was actually like a really hard A student who actually tried.
Aw, how nice.
Yeah. I thought I was in my friend group in undergrad. I thought I was the dummy, but that was because all of them had 4.0 GPAs, and I'm like,
Well, I mean,
That's how I feel with my friends, or at least most of them.
okay, yeah, I told my friends, I was like, yeah, I feel like the slacker, but they're like, shut up, you're doing really well. I'm like, okay, cool.
oh,
But yeah, I have no idea about Clemson's dorms. I know my dorm wasn't really fancy.
Isaac, do you like Weaver?
yeah, I do. The reason why is because I've I've been in like the cheapest living options with the shoe boxes, and then the most expensive, which are the honors and core, and then a little bit of Doubted. And among all those rooms that I've seen, Lever Hall and like the high rises in general make the most sense financially because they're kind of middle of the road price point wise, a little bit lower.
Oh yeah, absolutely.
600,
agree with
500
that.
per month. And they're also above the ground, so you avoid some of those issues with the shoe boxes with moisture and I guess
Ooh,
pest control. And
that's
then
true.
geographically on campus, they're next to like the most famous dining hall, first of all. And when you're situated east, you're
You
near
got this
a lot
all
of
laid out.
classes freshman year. Yeah, because I think like, did I make the right choice? All that. So
Oh yeah, no, I like living in there. I just like it because there's a lot of people that are doing the same thing as me, so I can just ask other people questions.
yeah, exactly. And you're not exactly
Yeah.
distracted with your
Uh,
all of like-minded people. That's
yeah, I couldn't really do that when I was undergrad because I did. I started in my Cal sequence. I actually took Cal 2 my first semester in
Oh,
college.
really?
Yeah, so my high school was a 1A school, so we only had AB.
Okay.
Oh,
So, and I didn't even know what BC was until I like took the AP test, and I was like, "What the fuck's a BC?" And then I looked it up. I was like, "Oh,
it's like a whole
I
nother
could
language.
essentially." Well, I actually looked, and I'm like, "So you're telling me I could have gotten a year off instead of a semester
Yeah, basically.
credit?" So I was a little peeved, but oh well. So yeah, so for all my friends in my friend group in undergrad, uh, they like starting in Cal 1 while I started in Cal 2. So I was always a semester ahead
So
in
you could
terms of
warn them
that.
what was coming.
Yeah.
That's like
Oh,
so all my friends are in Calc 4 right now, so they can tell me everything.
Yeah,
so
my friends as well.
it's curious that y'all call it Cal 4 because that's 2080, right? So that's DPQ.
Yeah, it's Diffie
Yes.
Qs.
So
Everyone calls it Calc 4 though.
Yeah,
even
this
though
comes out
I
like
know it's
well,
not.
that's because y'all are required to take it. Like I think.
Yeah.
So I'll tell you right now for DPQ, it's cool, but I wouldn't really worry about it. Like it's not bad. It's not as bad as you think it will.
I've heard Calc 3 is not that hard either. It's just vectors.
Yeah. So the idea for Cal 3 is you're essentially generalizing all the stuff you learn in Cal 1 and Cal 2, but instead of one variable, multivariable.
Okay. Yeah.
Which means that you do have more cases, but if you know the intuition in 1D, then the intuition could help you out in like 2D and 3D and however many dimensions you're playing with.
10-dimensional calculus.
Oh, I don't think they'll do that for y'all.
I hope not.
Um,
I've seen some problems with 40 parts to it, which is just like insane. That actually might have been like the example how to do it. It was like 40 steps. But I see them, they take up whole entire whiteboards to do some problems.
Oh, nice. You can look like one of those professors on a stock image background.
Exactly.
First day of Calc 10. All right, cure cancer right now. What's the formula?
Oh well, my first day in college, because I could tell you all my Cal 2 experience. So my exams were 4 hours long whenever I took them.
What?
Yeah, and it was 5 problems, but each problem had 12 parts to it. And it was one of those tests where you use A for B, then use A and B to solve C, then use A, B, and C to solve D, and so on and so forth.
That's terrible.
So I'm the dummy who I actually liked that professor, and I was dumb enough that I took a couple more courses with him because he taught really well. But he, in terms of like learning, he'll kick your butt. Like to give you context, out of the 40 students in that Cal 2 class, I was the only one who came out with an A.
Ooh,
And I was
Jeez.
like, yeah. I had a
That's
friend
good.
in that class with me, and we called it someone walked the plank whenever someone dropped, because we started with 60, and then like a third of them left, and I'm like, oh, geez.
That's terrible.
Well, I don't know. I had a blast when I took the test. I like brought my food with me. I like
Any test, I like play heavy metal music and I'll start shadow boxing in my room. I have to like hype myself up to take it. It helps me do better.
yeah.
that's pretty nice. I should try that.
And so one of my classes I took with that professor was it was a math major course, like probability theory. And my friends and I, we laughed at it when we took it because the number for it was Math 420.
Nice. Oh
And
man.
and so every day we walked in, my friends and I would just pretend we're high, and we're just like, man, it's time to get lit. So and whenever any of our other friends who weren't in that class asked us how's it going, we'll just be like, bruh, I had an amazing experience in that class today, man.
I had an out of body experience.
Oh my god.
Yeah. Yeah, so
Great.
and that class was fun. It was just a dumb joke that I had while I was in that course. And I even told the chair, I'm like, do you realize that like people are gonna make fun of the course because of the course number? He's like, what was funny about it? And I'm like, oh geez, I don't really want to explain it to you.
That's awesome. It sounds like a experience. Oh wait, speaking of, I do have a question too about the final exams. I know that nothing's been.
Yeah, go for it.
My grade in Calc 2 right now is sitting at 85. I had like a 90, 91 by the first exam. Second exam, I scored lower. But
how's the grading going to be done?
Yeah, according to the email that I read a little while ago, it was there's the potential of replacing your second exam grade if you score higher. So
yeah, so
40%.
Yeah, so right now,
is it possible for me to bring this up to an A?
I say yeah, because right now, because test 3 is gone. Tests 1 and 2 are now weighed 30%, with the final still 20%.
Mm-hmm.
But I'll use my my cousin Bubba for an example. Let's say on test 1 he got a 92. And because test 2 was harder than test 1, let's say he scored
40.
Yeah, let's go that route. Let's say he scored a 40. Well, let's say he tried really hard on the final. And he scored an 82.
Mm-hmm.
So we're still going to do the policy where if your final is higher than one of your lowest test grades, we're essentially going to say, okay, well, I'm going to pretend that 40 didn't happen, and that's going to be 82, which in that case
would then bump her up.
Yeah, it'll be 40% for test 1 and the final. So that happens. Test 1 will now be weighed 40%, and test 2 and the final will be weighed 40%.
Okay.
Test 3? No.
Yeah, we don't have a test 3 anymore.
I meant test 2. It would just get rid of that completely.
Yeah, I'll pretend that test 2 never happened.
Nice. See, I'm mad at myself because I practically on test 2, I did know everything that I was doing. It was just stupid little stuff that screwed me over. It was like just like the tiny little things that like messed everything up.
I understand that feeling.
But like I
If
knew
you-
exactly why everything was wrong and like how I did it. It's just
yeah.
looking back, I'm like, oh my god.
To give you context, so when I was an undergrad, I took for math majors, it's called real analysis, and essentially to give you the gist, I don't tell you everything about calculus. I kind of tell you how to use it, but I never go through why, really. And that's because that's a whole course in itself to understand the reason why everything works.
Mm-hmm.
And I kind of did something like you did, Anthony. I had a test and I knew what I was doing, but because I made one tiny error, my professor decided to take 10 points off.
Oh,
And I even was like reasoning, I'm like, it's only a minor error. But he was like, still an error. So lose a letter grade. And I'm like, oh, geez. Holy crap.
that's a bit tough.
Yeah, he wasn't one of my favorite guys.
Yeah, I don't like professors like that. That's
Yeah,
kind of like my math lab professor.
Oh, gosh, yeah. But
Oh,
like,
mine too. Yeah.
I will give him credit because it was a major class. So everyone was sucking because the material was hard.
Mhm.
So my final grade was like a 74. But
Stacks and dynamics.
but we recalculated. But he was nice enough to say, since you had the highest grade, I had an A. Now it's because I think when the material is very hard, doing a 90, 80, 70 cutoff is too harsh.
Yeah.
Yeah, a little bit. I'll be
Just a little
honest.
bit.
So sadly for YIS course, we have to abide by it. But I think when it gets to like a 300 or 400 level course, it's relative to how everyone is doing.
That makes more sense.
Yeah. I'm wondering, I highly doubt, though, that for this one that they're going to make it optional. Because I know some of my other classes have started making it optional, like sociology, even though that's a gen ed, but engineering made theirs optional.
Yeah, thank goodness.
I don't know if physics did yet. They may have.
The way Dr. Brown was talking about it, I don't think they're gonna make it optional.
Really?
Yeah. I am hoping, however.
Yeah, I
But
would too. But I
if
don't think math's going to be optional just because there's so much for test 3 that like we just didn't apply then. Like
yeah, we're missing
basically,
a lot of content here by canceling exam 3. So either way, though, I do want to take this final because if I gamble and succeed, then I do secure an A.
I'm teetering on an A, so I don't want to take it.
Oh, you have an A right now, Anthony?
Yeah, I have like a 90.7.
Yeah. Oh my goodness.
So we could end with that. I'd be happy. Can end all my classes. I'd be happy with my grades.
Yeah, and like I said, that policy, since it's coordinated, I don't have the final control over it. That's up to Dr. Burr.
It'll be fine no matter what.
Yeah, A or B. I'd say that's a pretty good success story coming out of Calc 2. But I know I can hit that bar.
I don't get why Calc 2 gets the rep that it does. I don't think it's that bad.
If you don't pay attention, though, like think about like not everyone's coming to these lectures. Sadly, I don't know why.
Plus I took Cal BC already, so that might be a little bit why too. But
yeah, taking BC in high school I think helps with this as well.
Absolutely.
Well, also, like I've mentioned, like before spring break, when y'all got back test 2, we compared to how the other 1080 sessions did, we did really well.
Yeah, it was pretty nice hearing that we were like 6 points above average.
Yeah, we were. Yeah, to give you context, like I know I think one of my friends who's teaching Cal 2 as well, his average was a 71 or something like that. So so it made me happy at least that.
Right?
78.5 or something. I don't remember 100%.
Gotta have the change in there.
Which considering that test 2 was harder than normal, I will gladly take one of the highest averages in a heartbeat.
Yeah, maybe we've hit that combination.
Yeah, so
Involvement plus your skill in teaching the class.
well, this is my first time teaching Cal 2, so y'all
pretty good.
are honestly my guinea pigs.
It's pretty good.
So, all right. I think my roommate, we have homework, so
Yeah.
I think he wants to work on the homework with me.
Oh, absolutely. You guys have fun.
So,
I'm gonna go listen to 11.2.
All right. Yeah, we will get back on this next time. I will see y'all when I see y'all.
Awesome.
All right,
See
see
ya.
you, Scooter. See you, Isaac.
See ya.
Anthony.